Hi everyone, welcome to the second part of our two-part series about how to manage TLS certificates in Kubernetes. So in the previous video, we talked about the theory part. We discussed what we started with HTTP, then we talked about HTTPS. We talked about how TLS works, how this TCP connection is established, how the TLS handshake happens, etc. We also had a look on how the same thing works with a Kubernetes cluster, how this client and server connection is between different components of Kubernetes. I hope you watched that video. In this video, we will do hands-on about this. So we will create a new user and then we will make sure that that user is added to our Kubernetes cluster, and we will create roles, role bindings, etc. for that user. So let's get started. Let us first go to the Kubernetes documentation. So we will follow one uh, part of documentation for this video. Let me search certificates for that. Certificate and certificate signing request. And this is the part we will follow. So how to issue a certificate for a user? Because we want to start with creating this certificate. Let me actually first give you a visual representation of what we are going to do, because this is quite confusing at times. So if I show you a visual representation, that will be much more easier to understand. So let us say this is a user and the name of this user is Shubham, right? And then there is another user who is cluster admin. Now what we want to do is there is a Kubernetes cluster. So this is a Kubernetes cluster. Now what we want to do is this cluster admin is a admin to this cluster. Now we want to make sure that we add Shubham also to this cluster and provide him some, let us say, some permissions. Like, let us allow Shubham to access the pods, to get pod, like he can perform kubectl get pods, he can perform kubectl create pod, etc. But only providing access of pods. Shubham should not be able to do anything or should not be able to access the deployments, etc. So how do we do that? So what happens here is Shubham has to provide his private key as well as a certificate. So Shubham will provide a private key as well as a certificate signing request that is created by the help of this private key, and it will be provided to the cluster admin. Now what cluster admin will do is cluster admin will create a CSR object, certificate signing request object, in the cluster. And this cluster admin will also do one more thing. He or she will approve the CSR, certificate signing request. So this is how it works. Shubham, who is a new user who wants to get added to this cluster, will provide private key and CSR to the cluster admin. Cluster admin will create this CSR object and approve the CSR. After approving the CSR, what cluster admin will do is cluster admin will get this what do you call it? Certificate. Uh, Let me remove this. How should I add it? Not this. What's wrong? So the cluster admin will get a certificate. See, do not get confused about this thing. This is a certificate signing request. It is a request. And right now what we get is a certificate. And this certificate will be then provided to this user. And now whenever this user has to use or has to like whenever this user tries to access this Kubernetes cluster, he or she will use this certificate so that they can get the access to the cluster. This is the basic idea. Now there is a lot more things like we will have to create the roles. So the cluster admin also has to create a role for this user so that this user can do certain things and cannot do certain things. But this is the high level idea basically, that the user creates private key and a CSR, and the cluster admin will create this CSR object in Kubernetes cluster, approve this CSR, and then provide certificate to the user. Now let's get started. Let us do the hands-on now. So for that, firstly, we will create a private key by the help of OpenSSL. So let's come here and we will create this private key. I will call this shubham.key. And firstly, I think I have a few files in this folder. Yes, I do have them. So I'll have to delete them. Yes, now we can get started. Use that command. We'll have to copy it again. So what we are doing here is we are creating a private key. Let us call this shubham.key. And now we have this private key. Let me show you how this looks. So this is how the private key looks. Now using this private key, we will create a certificate signing request. So let's go back. And the name of our private key was shubham.key. So using this, we will create a CSR. Let us call this CSR shubham.csr. And let us call this shubham. So now we do have a shubham.csr. Let us also do a cat in the shubham.csr. So this is how it looks. It is a certificate request. And are we missing anything? I think it is good. CN basically means common name. So we have set it to Shubham. Let us go back and now we can create a certificate signing request. So this is how it looks. Let us copy it from here. We can also use methods like kubectl create dry run so that we can figure out how this certificate signing request can be created. But for now, let's do it using like by copying this because it's much more easier that ways. So what I will do is I'll create a shubham csr dot yaml file and I'll paste it here. Now the thing is this request must be something else. We have our own request, so we'll have to use that one here. We'll write this request and we'll go back. Now what we have to do is we have this shubham.csr, right? So this will go as a request in the request field of this file. So how do we do that? For that, firstly, we have to make sure that this is base 64 encoded because it is not currently. So what we will do is we will say we will print data inside it, send it to a pipeline, and then base 64 encode all the data that comes here. And then we will make sure that there is no line break. I think this is it. I think this should be correct. Let me copy it and let me first show you something else. Shubham.csr. So we want to base 64 encode this. Now, if you see this, here is a line break. So after every line, we have a line break here. But we cannot add a line break to our YAML, right? That's why we want to remove all the line breaks. So we will do this thing. Yes. Let me do it again. Okay, I made a mistake. Why is there no single quote? There should be a single quote here. Now it should work fine. Here also we can see some spaces. I don't know why. This is the correct one. I'll have to do it again because I cannot see the last line because of the screen recorder. So I'll do this again and copy it from here till here. And now we can go to our Shubham CSR, and in the request session, we can copy this, and I think it should work fine. So this is a certificate signing request. The name should be changed. Let's call it Shubham. And let us extend, or let us add more time to our expiration seconds. Let us make it 10 days. Or I think now it is good to go. So we can apply this file. Context was not found for specific context, Shubham. What is the issue? Context, Shubham. Let me first check the context. There is no current context. Use context, let us say cluster 3. Okay, kubectl config. And now if we do get contexts, I think now it should work. So I'm pretty sure you will not have to do these things because this was very specific to my cluster. Because what I did was I created a context and I deleted that context also while being present in that context. That's why this issue occurred. This will not occur in your cluster, I'm pretty sure. So now if I try to do the same thing, kubectl apply, it will be created. I think you can directly do this. So now that the CSR has been created, let us do kubectl get CSR, or you can write kubectl get certificate signing request. And you will see we have a certificate signing request called Shubham, and it is still in pending state, and the requester is Kubernetes admin. Now, one thing I should also talk about is this. So here, Shubham and cluster admin, I am playing the role of Shubham as well as cluster admin. So I created the private key and CSR on behalf of Shubham, and I am also the cluster admin here. So that's another thing. Otherwise, in real world scenario, somebody else would have given me private key and CSR, and then I would have created a CSR object, and then I would have approved it. So requester is Kubernetes admin, and it is in pending state. Now let's approve this kubectl certificate. Proof name is Shubham, and it has been approved. One more important thing here is that here we are not calling it certificate signing request. Here we are saying kubectl certificate. So people tend to forget this. So you should remember this. kubectl, not certificate signing request. It is kubectl certificate. Approve Shubham. Now this is approved. So we can do this again. kubectl get CSR. You will see that it has been approved and it has been issued. Issued. Yes. Now let us go back to our documentation. I don't remember the next step. So certificate signing request was created, and we also did this, took the CSR and added it to our shubham.csr, shubham.csr.yaml. And then this thing we have done, we have approved it. And now we can get the CSR object. I don't know why are we doing this. I think we don't have to do this. We can directly go here. Okay, let us once do it and see what the output is. So kubectl get CSR. No, kubectl. How do we do this? Let me check. Okay. So even I don't know this. kubectl get CSR. My user is Shubham. And the output will be given in the form of YAML. I don't use this actually. I rather use this thing. kubectl edit. So I can also have a look at the file and I can also edit it. But let us exit. Let us do the correct command. So this was kubectl get CSR Shubham -o. The output should be in the format of YAML. So I think what the tutorial is trying to say is that the certificate is present in status dot certificate. I think that is it. Yes. So we did not have to do this actually. We can directly come here. So what's happening here is we are going to take this CSR. So we created this CSR called Shubham, right? And then what we are doing is in the output, we'll take this JSON path and in status.certificate. So if you remember what happened in status.certificate, let me copy this and show you again. Okay. In the status.certificate, what do we have? We have the certificate that has been created. So if you remember here, we are now going to provide certificate to the user, right? So what happened is we created a CSR and the CSR had what? CSR had this CSR as request. So in the CSR we created, in the request file of that CSR, we had this CSR, right? So once that is approved, in this CSR object only, the certificate is also added. So earlier the CSR only had the this CSR in base64 encoded format, and now this CSR also has a certificate in base64 encoded format, and now we want to give this certificate to this user, but we want to make sure that this is not in encoded format, so we have to decode it. That's what we are doing here. So the certificate is in status.certificate. Now if you look at this, why is there a space? Yes. So if you look at this, we are doing get on CSR called Shubham. In the JSON path, you'll see in the status.certificate. What happens in the status.certificate? The certificate is present in encoded format. And then what we are doing is we are decoding this. -D is for decode. So you can write -D or you can say the -- decode. DCODE. and then we will decode it, and then we will keep the output in a file. Let us call it shubham.crt. And now if you look, we have these many files. So firstly, we created shubham.key. Then we used shubham.key to create shubham.csr, certificate signing request. And then we used this data in this YAML file so that we can create a CSR object. So this created a Shubham CSR object. Shubham object, like the name of that CSR was Shubham, and it was created using Shubham CSR.yaml. And after that, we got a certificate in this YAML, and we created shubham.crt in that YAML. And now we will provide this CRT to the user. Whenever the user will try to access the cluster, he or she will do this with the help of this certificate. So now what we will do is, let's go back. I think now we will create a context. So we are first creating this role binding and role. Okay, let's do this first. So now what we will do is, we will create a role. Now what is a role? So I think I should make a separate video on this RBAC role-based access control. But if I have to give you a brief introduction about it, how that works is, me copy this here. So let us say we are this person and we have a company, and a new employee comes into our company. So this is employee one. He comes to our company. Now he will require access to the resources, right? To the computers, to like internal portals, etc., other things. So now there are two ways of doing it. Either when a new employee comes in, we will say, okay, we will grant you access. So I will grant him access, right? And then when a new employee comes in, employee two, then I will say, okay, you also are given this access. So let us say employee one is a developer. So we will give him access to, uh, what should I say? Let us say developer tools, right? And then employee two comes in, who is an SRE. So we will give access to something else. Let us say infra, anything. And when employee three comes in, so if you look at this, we are doing this manually every time. So whenever a new employee comes in, we have to do a particular task. Whenever new employee comes in, we have to give him or her requests. Now this is very difficult to scale, right? So for every employee, we have to do some manual work. So this is the normal way of working. The other way of working would be role-based access control. So this concept of role-based access control is not just in Kubernetes, but in tech, or in anywhere in general where there is an organization. What we will do there is, this is me. I will create a role here. I will create a role here called developer. And this developer role will have certain permissions. For example, he can access, he can make direct changes to code. He can launch PRs. Right now, I cannot think right very good examples. So please bear with these examples. Please bear with these examples. So now what happens is, okay, let me create one more role. So I'll create one more role called SRE, and he can make changes to the infrastructure, and then he can deploy changes, etc. Now what happens is, whenever a new employee comes in, whenever there is this employee one, whenever a new employee comes in, we can directly assign him or her a role. So we'll assign him dev because he was a developer. And when new employee comes in, employee two, we can assign him SRE, this role. And then new developer comes in, new role, right? uh, we can assign him these roles. So now what happens is, with this thing, every single time we are performing the repetitive task, if the employee 3 is dev again, so we have to again provide the same thing, the same permissions, which is very cumbersome, and which is not very scalable, right? So now what we do is we create this role based access control. And in role based access control, we have created these roles. Now let us say n number of employee comes in, we just have to provide them a role, and that role is associated to different permissions. And this is the better way of working. So this is what we called role based access control. Similar to this, like the same thing happens in Kubernetes as well. Consider these to be, for example, these are roles. So let us say this, in this developer role, in Kubernetes cluster, developer can create pods, and developer can get pods. SRE can, let us say, create deployment and delete deployment. So this works the same way. Whenever a new user comes in, we can simply assign this user with this role. So whenever the user will do kubectl create pods, he will be able to do it. But if user one will do kubectl create deployment, he or she will not be able to do it. So this is the basic idea behind it, that we are not doing this manual task for every employee. We are not trying to create new permissions. We are simply creating roles and then assigning those roles to the employees. So that's what we are doing here. We are creating a role here. So the role name is developer, and then verb create. Let me first show you resources. So resources basically mean what resources can be given access to. So if there is a user who has the role of developer, he can only access pods. So he can never do kubectl create deployment or get deployment, anything, nothing. And then with pods, now we also have to make sure that we don't give all the access for a pod. So for that we have verb. So this is the resource, and verb basically mean the action that are allowed to be performed. So create, get, list, update, and delete. This basically means user can create, get, list, update, delete only pods, right? And if I remove this, then user will not be able to delete pods. So that's how it works. So this already exists for me. Let me do kubectl get role. We already have this role. I think we should create it again. Maybe there is some mistake in the earlier role. So this has been deleted. Let us create this again. So now we have created this developer role. We will similarly create a role binding. Let me first delete the role binding if I have any. I do have two role bindings. I should delete them. Now let's get back to our documentation. We created this role. Now we will create a role binding. I'll explain you what role binding is. So now what is role binding? See, we created a role. We have a user. Now how do we make sure that this user will only get this role? We do that by the help of role binding. This is a role, and this role will be binded to this user by the help of role binding. So that's what role binding is used for, so that we can give this role to the user. Simple as that, very simple, right? So that's what we are doing. We are saying that to the user called Shubham, we will give this role of developer. And we will name this role binding. So I don't want to name it this. That is called dev role binding. So we have created a role binding with the name dev role binding, and the role of developer will be given to the user named Shubham. We have not created a user, we'll create it later on. So whenever a user named Shubham will be created, he will be given or she will be given access to this role, developer role. So this has been created. We'll do kubectl, kubectl describe. Let us describe the role first. The role was developer. Let us see. So if you see here, we have access to the resources called pods, and the changes we can make in pods is create, get, list, and update. Similarly, let's describe role binding. So I cannot see this because of, let me do it again because I cannot see the final lines. Yes, so we have this role called, like we have the role called named developer, and that should be given to user called Shubham. So that's basically how this works. Now that we have given a role, we can do other things as well. So we use this command called auth. So kubectl auth, and then we can check who am I. This basically tells us who, like what we are in the cluster. So we are a Kubernetes admin, right? And we can also do things like kubectl auth can I get pods. So this will tell us if we have the permissions to get pods or not. So obviously we are the admin, we can do anything. So we do have access to get the pods. Now, if I say kubectl get pod, and if I add as here, we can also like stimulate the condition if another user is trying to do this. So the username was Shubham. We have created this role. So can Shubham create like get pods? Then yes, Shubham can get pods. But can Shubham get deployments? So no, Shubham cannot get deployments because we saw that Shubham role, the role that Shubham has only has permission for pods. And even in pods, Shubham does not have access to delete pods. So if we do delete pods, then no, we do not have access to delete pods. But right now, what we did was we are trying to stimulate that condition, right? We are not actually becoming Shubham and doing things. So let us do that. Let us switch our context. Let us create context and switch our context. So we will create new credentials for Shubham here in our kubeconfig file by this command. kubectl config set credentials for Shubham, and the client key should be shubham.key, which is present in this folder only. And the certificate is Shubham certificate. So this is where like this is what we wanted to, this is what I talked about in this folder, in this diagram. Where is it? Yes. So we gave the certificate to Shubham, and now Shubham is doing this task. So Shubham in his kubeconfig is using this certificate and is using this key. So why did we not give key? Because Shubham created the key, right? He has the key. Shubham created the key, gave it to the admin, and admin gave him back this certificate. And that's how we will do it. So I think this is clear. And then embedded certs. Embedded cert basically means, see, there are two ways of working on the kube config. In the kube config, either we can provide the path of files of these two, but what if we change the path of file, or what if we remove it from this folder and keep it in some other folder? So that is a problem, right? That's why we do this embedded search. What this does is, rather than adding path of files, it will directly add the encoded format in the kube config. So even if we change path of file from this thing, like from TLX to we create some other folder and keep these keys and certificate in some other folder, it will still work. That's why we have set it to true, and the user Shubham has been set or created. kubectl config get users. So we can see we have a new user called Shubham. If I do kubectl config, I'm not sure if you can do that. I want to describe the user. Can we do that? Get users, delete user. Uh, I don't think it is available, so let us ignore that for now. Let us move to the next task. Now we will add the context of this user. So we can create a new context of the user called Shubham. And the name of this context, let's call it Shubham CTX. The cluster name, what is the cluster? I don't remember the cluster name. So let me copy this and let me say k config uh, get contexts. So the name of cluster is kind CKA cluster 3. So this context has been created. So when we do kubectl config get contexts, then we do have this Shubham CTX. But the current context is which one? This one, cluster 3. So we have to bring our current context to Shubham. For that, we will do kubectl config. We will set, I think it is use config, use context, Shubham CTX config, kubectl config, user context. No, it is use context. So now the context is switched to Shubham CTX. Let us do kubectl config. Let me clear this again. It contexts. So now the current context is shubham.context. Let us see if we are missing anything. So I did this command and then we change the context. So use context, I've already done this. So now if I try to run kubectl get pods, there is no resource. So now if you see, we are Shubham. So we cannot do kubectl get deployment. See, we cannot do deployment because the access is forbidden. User Shubham cannot list resource deployment in the API group apps. Why? Because we have only provided limited access to user. So this is how Kubernetes enables like different users to come in and how we can use Kubernetes to create new users, how we can manage TLS certificates. So now Shubham has limited access while the cluster admin has all the access. So if we do kubectl get path, it works, right? It works, but there are no resources. We can also do kubectl. We cannot do what things we cannot do is kubectl get let us say nodes. So this is also not allowed. So I think I have covered everything here. So we talked about the theory. We talked about a little bit about how this works. I also talked about how the RBAC works. And I'll make a separate video about RBAC where we will talk about roles, role bindings, and everything else like certificate. No, not certificate. Like uh, like service accounts, etc. So that we will do in a separate video. But I hope you understood this video and this was clear for you. So I hope this video was clear to you and this helped you understand how we create these users and how we can manage certificates in Kubernetes. If you have any doubts or if you want to discuss something, feel free to reach out on comments. And thank you for watching this video. I'll see you in the next one.